So let's look at a different graph. So I've got the graph of y equal cosine of x. So you know it's like that. And then I know y equals 0, x equals 0, and then x equal pi over 2. So that would be where it crosses here at pi over 2. So there is my region bounded. So let's go find just the, let's go find the m. So the m is going to be the area bounded. So x equals 0 to pi over 2. Pi over 2 of cosine of x dx. So that gives me sine of x between 0 and pi over 2. Hey, that just gives me 1. Okay, well, that's nice. So with m equal 1, I don't even really have to worry about it, right? Okay, so let's go find the m sub y. So m sub y is the integral from 0 to pi over 2, and the m sub y is the x times the function. X times the function cosine of x. And you've been doing so many integrals, you see that this is integration by parts. So let's do u equal x, dv equal cosine, du is dx, v is sine. So this gives me uv minus the integral of v du. So this x sine of x carries along, and I take the antiderivative of sine, and I get negative cosine, so this turns into a plus cosine. So between 0 and pi over 2, if I plug in pi over 2, this gives me 1, so I get a pi over 2, and that gives me 0. But don't forget to subtract plugging in 0. This gives me 0, and that gives me 1. So that's my y bar. So that's my moment about the y-axis, m sub y. So my x bar is equal to pi over 2 minus 1 over 1. I'm just emphasizing that. I'm using that. Okay, so now let's go do the other one. So the m sub x is going to be using my m sub x moment, but about the x-axis. So that's 1/2 f of x squared. So 1/2 f of x squared between 0 and pi over 2. Okay, so you know that you need the half angle formula. So that's 1 plus cosine of 2x. And so that's 1/4 and x, and then 1/2 sine of 2x between 0 and pi over 2. So I plug in the pi over 2, and I get pi over 2 here, and this would give me 0. And if I plug in 0, I get 0. So this means that just write it in a different color underneath, my y bar, okay, not a different color, is pi over 8. So that is the center.